Hello, am I audible?
Yes, sir.
Yes, sir.
Yes, so yeah, very
Yes,
good
sir, you are
evening
audible.
to all of you. So, okay, so this is the activity practice session uh, for week 10. So, we will cover who has the doubt regarding week 10, any activity, any practice question, or any concept, and all things. So, please raise your hand and we will discuss one by one. Hope you have covered the all the lectures and lecture video of week 10, right?
Yes, sir.
Okay, nice. Someone named Dale has raised hand. Yeah, please. Hello. Well, if you are speaking, then you are not audible to me actually.
Good evening, sir.
Yeah, good evening. So, yes. Okay, so anybody? Dale, you are not audible. I think he has left. Yeah. Anybody else? I mean, who has doubt regarding week 10? I think any concept, any activity, any practice question. So please raise your hand and we can discuss. Inumola Karthik, yes, please. What is your doubt?
Yes, sir. Good evening. Just a couple of questions from my side.
Yeah.
So, regarding Bernoulli random variable,
Mm-hmm.
so is it like any variable that can take only two values? Is that a Bernoulli random variable, or is it something specific?
No, not specific. Something, suppose you performing any experiment or any random variable that takes two value, like suppose 0 or 1. 0 or 1 means 1 is for your success, 0 is for your tail,
Yeah.
failure, right? So that type of random variable is called Bernoulli random variable. Let's take example of tossing a coin, right? Then you have only two choice, either getting head or tail. Suppose you are interested in getting head, okay? So you will introduce x equal to 1 if it represents head, x equal to 0 if it represents tail. Then it becomes the Bernoulli random variable. So whether random variable, if for every tile, for it has two chances, okay? One is for your success in which you are interested in one for the failure, then it will be the Bernoulli random variable.
Okay.
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 And if you perform, yes, please.
Yeah, no, go ahead.
Yeah, if you perform Bernoulli random variables up to n trials, then you will cover, I mean, it will become binomial random variable.
Okay. Okay.
Yeah.
Okay. So in lecture 10.3, there was
Mhm.
this concept of expectation of the sums of random variables.
Okay, yes, yes. Yeah.
Where ma'am has covered the sum of all the expectations. So let's say the example was toss a coin three times,
Mm-hmm.
and the sum was 0.5 into 3. So 0.5 is the expectation of a single toss of a coin.
Okay, yes.
So the total came up to 1.5. Now,
Mm-hmm.
if we separately calculate the expectation directly of three tosses, let's say it also comes to 1.5. So what she showed was the concept with the single toss.
Okay.
Expectation of a single toss. So then this concept was applied in a general way. Like if you toss a coin I times, then your sum of all the tosses will be 0.5 into n. N means number of tosses, whatever there are.
Yes, yes.
So this concept can be applied to any scenario, or is this again specific? Because
No, no.
let's say if
You know property of the expectation. I mean expectation of summation of xi. One second.
yes, it is the sum of the individual expectation.
Some of the individual expectation. Okay. So do you know time is time? And do you remember?
10.3, this was, I think, towards the end, I think.
And at the end, right?
Yeah, see this one. So
Yeah.
this is experiment of tossing coin 3 times. So
Hmm.
earlier, how we were calculating the expectation was like we were taking the whole sample space. So starting with H, 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 and so
Yeah,
on.
see, it's okay. See, suppose you have three random variables, right? X1, X2, and X3, right?
Yeah.
Suppose you are interested in the what is the expectation of sum of all these three random variables, okay? Then you can compute it is, I mean, you can compute as a individual sum of the individual expectations, right? So you
Correct.
can do it for any example. Okay. See, this
Okay.
expectation property will be applied for every random variable, whether it is dependent or independent. But if you see in the case of variance, this should be equal to variance of the sum of the random variables when variables are independent, right? No, you
Yeah.
have remembered that, right? So you can apply this property for any example. It will work.
Okay. So like, I mean, there are multiple ways of, I think, doing
Yeah,
the
you can
same
do.
thing. So I was
Yes, yes, yeah. No,
just
no, no.
wondering that. Okay. Sir, final question. So regarding this independent random variables,
Yes.
uh, is there any actually specific method to know whether the random variables are independent? Because ma'am has showed only the examples where it is evident that the random variables are
Mhm.
independent. But
No,
is
you
there a
have
way
to
to know?
actually, yeah, you have to actually think whether it is independent or not. Otherwise,
Okay.
it will be mentioned in the question it is independent or not. Okay. Suppose tossing a
Okay.
coin, it's kind of it's obvious thing. Trial will be independent, right? Getting head is independent of getting tail, kind of things. Okay. You
Yeah.
roll a die. In that case, it's independent. So in some cases, it's obvious. If it's not obvious, then it will be mentioned. Yeah. Suppose I write only x1 and x2 in general, right?
Mhm.
Then I must have mentioned like x1 and x2 are independent. Then what will the variance of x1 plus x2 kind of things?
Okay.
Okay, it will be mentioned. If it's not obvious, then it will be mentioned about the independence thing or dependency, right?
Yeah. Okay. Okay.
Is
Okay.
that
Yeah.
clear?
I think. Yeah. Yeah. Thank you, sir. That's it from
Yeah,
me.
thank you. Tail has raised hand. Yes, Dale, what is your doubt?
Sorry, sir, I got disconnected earlier
Yeah,
before.
no, yeah,
The
it's
10.2, question number 9, sir. How to
10.
calculate the n?
Yeah, once again, 10.2 question
Last
number.
question, sir. Even I have two questions also, but this is the first one, sir. I want to know.
Okay, is the expectation of uniform distribution whose probability mass function is given this, then value of n. Okay,
Yes, sir.
see first, can you tell me what was your approach for this one?
Just I went through the video, sir, and I got the formula that it's sum of xi into p of xi and
Mhm.
n 1 by 2.
Sorry.
N plus 1 by 2 is equal to sum of xi into pi.
Okay, yes, I mean you got expectation of x as
Xi
summation of xi into
into
pxi.
pi.
Okay,
Yes, sir. Yes, sir.
I equal to 1 to n, and you got this as n plus 1 by 2, right? By
Yes,
the
sir.
see, how did you get that? Then there is formula like x is your 1, 2, so
2
on up to n, and
and
probability of
p of
x
x
is
is
see,
equal.
for one, I mean probability is constant. That means uniform for each value
Yeah,
of x,
uniform
right?
distribution, sir.
So
Yes, sir.
yeah, if yeah, there is a theory concept, something. Suppose your x is a random variable which takes value 1, 2 up to n, and probability for each value is constant, right? Is same for
Yes.
all the values. Then
Yes, sir.
this type of distribution or this type of random variable is called the discrete uniform random variable, right?
Yes, sir.
Okay, so this random variable x is called discrete uniform random variable. Now, what is the concept of expectation? This is nothing but the summation of xi into pxi. Okay, that
Pi.
means
Yes,
1
yes,
into
sir.
1 by n. Okay,
Plus
plus
2
2
into
into 1
1 by
by n,
n.
plus so on, plus n into
N
1
into
by n,
n by. Yes,
right?
sir.
If you see 1 by n, I can take as a common.
Yeah.
That means I have these things as remaining, right? So
Yeah.
if you know sum of these n natural numbers is n into n plus 1
N
by
plus
2,
1 by 2.
and this n. Okay, now this n is got cancelled out by this n, right? So for this example, if you remember, then you can directly use the expectation of x as a n plus 1 by 2, right?
Okay.
Now come to the question. What is the question? Expectation of uniform distribution this whose probability mass function is given this table is 10, then value of
10.
n. Okay, so this value is given as 10, right?
Okay.
So n
Yes.
plus 1 will be your 20, 2 into 10.
Okay. 20
So n will be
minus
19,
1.
right?
Okay. Okay. Correct,
So
sir.
I think 19 is the correct answer.
Yes, yes. I went up to n plus 1, sir. N plus
No,
1. After that,
no,
okay,
no,
sir.
in the question it's given that key expectation is 10, right?
Yes, sir. Yes, sir.
Got
So
it?
1 by 2 is equal to 10. Okay,
Yeah.
sir.
Okay. Okay, after you, Sujay has raised hand. Yes, Sujay.
Yes, sir.
What
Good
is your
evening, sir.
good evening?
Sir, expectation of random variable.
Hmm.
I understood as uh, after giving the probability, what is the most in this expected value of x? I am correct, sir? Am I correct, sir?
Can you repeat?
What expectation is the English word is there for English word expectation.
Yes, yes, yes.
I am relating same thing to expectation of x, but
Yeah.
I can't relate variance of random variables, sir. I cannot
Okay.
visualize what variance is. As expectation, I can see that it's a mean value of
Okay, I
random
mean,
variable.
you are able to interpret what is expectation of x, but you are not able to interpret what is the meaning of variance of x, right?
Yes, yes, sir.
Okay, you understood what is the meaning of expectation of x? That is nothing but the it's the expected value of random variables x, which tells you like we can expect like the average of large number of trash to be in the, I mean, you can say long run average, right?
Yes, sir. Yes, sir.
Suppose x is experiment, you can do like suppose you are doing an experiment rolling a die, right? Okay, then what value x can take value 1, 2, 3, 4, 5 and 6, right? What will the probabilities for each one? 1 by 6, 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 1 by 6. Okay, then what will be the expectation of x? 1 by 6, 1 plus 2 plus 3 plus 4 plus 5 plus 6, right? Is that clear?
Hello.
Yeah, is this clear?
Yes, sir. 1 by 6.
Yeah. Now, so if you compute, then it will be, I think, 6, 5, 11, 15, 18, 20, 21 by 6. So it will be 3, 3.5. Yeah, 3.5. Okay. So what is the meaning of this 3.5? So meaning of this is, you can say, after long run, after long run average, you can expect as a average 3.5. Okay. This is the something which you give the long run average. Okay,
Yes, sir.
right? So this is the meaning of expectation. This till this point it's clear, right?
Yes, sir.
Now come to the variance. Okay, what is the variance? So variance, by the word variance means you can interpret as variability, right? Now if you see, by the expected value of random variable gives us a, like you can say, weighted average of the possible values of random variable, right? This is something weightage average,
Yes, sir.
right? But in the variance, like, but this expectation did not tell us about variation of the values, right? So for, I mean, for getting
Values
the
of
information,
x.
yeah, for getting the see, x is taking this value 1, 2, 3, 4, 5, 6, right? So expectation just tell about the expected value of x for the long run average, right? But but expectation did not tell us about the variation of the values. Okay, how our values are varying. So for this, variance comes into the picture, right? Now what is the variance? Variance, if you see, variance is nothing but the expectation of x minus mu whole square, right?
Yes,
So
sir.
variance tells us the variation from the mean value from its, I mean, from the values of x. Okay.
No, where variance is not clear, sir.
Okay, so let me insert a new thing. Okay, see, variance is what? Basically, variance tells us this is the formula of variance. Right?
Yeah, yes,
Yes,
sir. It's a formula.
So what is this? This is mean.
Mean.
This is your random variable. Okay.
Random variables.
Suppose I'm taking as, just take this is your x. Okay. And suppose this is the mean. Okay. Right. So we will see how far is our values of x from its mean. Mean
From
what
its
is the
mean.
variation of the values from its mean.
Okay, sir.
That
Okay.
is about the variability of the values of the x we compute by the formula of variance of x, right?
Yes, sir.
Got it, sir.
Clear,
Okay.
sir.
See, what is this? What is the x minus mu whole square? You got it, right? Expectation means what? So it's nothing but on an average we will see the variability, right, of the x from its mean.
Mean.
Is that clear, Sujat?
Yes,
Yes,
sir.
Okay.
Sir, in discrete uniform random variable,
Yeah.
can we say variance is n minus last value of variable, last value of random variable minus starting value of random variable?
Variance of x in discrete uniform. You are saying what?
Last exercise, die rolling a die 1, 2, 3, 4, 5, 6.
Okay.
Probability is uniform, right, sir?
1 by 6, 1 by 6, 1 by 6. Okay.
Here, can we say variance is 6 minus 1?
No, why 6 minus
1? We
See,
need
where
to
you are
calculate
doing
that.
range. You are if you are saying 6 minus 1, then you are computing range, not variance.
Okay, sir.
Okay.
Okay.
Variance means, see this formula. This means variability. I mean, what is the deviation of values of x from its mean? That's it. In general, we are interested in to know what are the variations from the values of x from its mean, from its average value. That's it. Okay. And what expectation tells us? Just a long run average, but variance will tell you this, I mean, values of x and deviation from its mean. That's it. Is this clear?
Okay, sir.
Okay.
Thanks, sir.
Yeah. And okay. No raise hand. Yeah, Raghu. Yeah, Raghu. Yes.
Yeah, sir. Good evening.
Good evening.
Sir, in the same context, for the question in activity 10.4.
10.4.
First question.
Yeah, 1 second, please. This one.
Yes, sir. So
yeah.
I have calculated variance of all these individually. And then I found the answer is 2, which is right.
This one. Okay.
Correct.
Yeah.
So
okay, correct.
There was one guy who was asking this question, that difference between the x last value and first value will always be highest. So is it just coincidence that in this question also, if I calculate just the difference between x last value and first value, option number 2 happens to be the one with highest difference or highest range?
No, highest range is for this. What I told you about variability. Variance is telling you about the what I tell, yeah, variation of the values of x from its mean, right? If you see, you can compute the expectation, I mean expectation of x, right?
Yes, sir.
Not expectation, you can say just like x minus mu. Okay. So if you see, you have to check which value, I mean, is more, I mean, for what, I mean, sorry, for which option deviation is more from its mean, right? Suppose
option
for
is
the
B,
first,
sir. I got the answer right. What I have done is, for all these tables, I have calculated the variance.
Let me explain.
Sure.
Suppose for the first one, values of x is 1, 2, 3, 4, 3, 4, 5, right?
Correct, sir.
Okay. What will be the mean for this one? For this values?
9,
3, sir. 3.
7,
3 will be mean, right?
3. Correct.
Now, for the second option, what is the values of x? 2, 4, 6, 8, 10, right?
Yes, sir. Correct.
What will the mean? It will be 18 plus
6. 6.
28 plus 30. 30 divided by 5, 6, right?
6.
Now,
Yes, sir.
what is the values for third option? 1, 2, 3, 4, then 2, 4, 6, 8. 1, 2, 3, 4.
2.5.
What mean will be 2.5 and 2, 4, 6, 8, right? It will be 10, 10, 20, 20, 25, 5, right? Now,
Yes, sir.
what variance tells us? These things, right?
Yes, sir.
So if you see this values of x, deviation from 3 is minus 2,
Okay.
minus 1, 0, 1 and 2, right?
Yes, sir.
For 6, if you see minus 4, minus 2, 0, 2 and 4, right?
Yes, sir.
For this one, if you see, it will be, I think, minus 1.5, minus 0.5, 1.5, 0.5. It will be 2.
Yes,
That's
sir.
0.5.
No, 0.5, then 1.5, right?
1.5. Correct.
Yeah. So for this, it's 5, so it will be minus 3, it will be minus 1, it will be 1 and 3.
It is 8, sir. So it is 3. Correct.
Okay.
Yeah.
Which for which option, for which values of x, your deviation is more from its mean?
Arithmetic sum of all these. No.
No.
Basically, it is 0.
No. You need see, if you see for this second option, deviation is more, right?
Correct, sir.
You have to do square, so you can do 16, 4, 4 and 16. If you see values, I mean deviation is more for this one
Forty.
as compare for the all options, right?
Yes, sir. Yes, sir.
So directly you can say like deviation from its mean for this option is I mean maximum, so variance will be maximum. That's it.
Oh,
Sir,
okay.
I have a question.
Yeah,
Okay.
yes, please.
Sir, you went with a formula like x minus mu the whole square, right?
Hmm.
I googled like earlier when I was solving, I googled for the formula and I got this formula: e of x square minus mu square. So can you tell us like when to use which form?
No, see, you can you can uh, you can use both one. See, till
I
this
think,
point,
sir,
so
it is expanded form of this.
yeah, it's the expansion of that one. I will explain. Yeah, till the this things is clear how I computed this one.
Yes,
Yes,
sir.
sir. Yes,
Because
sir.
I have been using that other formula.
No, you can see variance of x. It tells you the this one, right? So can I write expectation of x square minus mu square? No, plus mu square minus 2 times of x mu, right?
Sir.
Just expansion of a minus b raised to a whole square, right? So expectation will inside the brackets will be expectation of x square, expectation of mu square minus 2 times of mu, expectation of x, right?
Yes, sir.
You know, expectation of constant is same as that constant. No, see, sorry, this is expectation of x square, this is expectation of minus 2 mu, expectation of x is what? Mu,
Okay. Yes.
right?
Yes, sir.
So I can write expectation of x square plus expectation of mu square minus 2 mu square, right? So expectation of x square plus mu square minus 2 mu square, right?
Okay,
So
got it, sir.
expectation x square minus mu square, mu is nothing but the expectation of
Expectation of x.
X whole square.
right?
Yes, sir.
This is nothing but so you can use any,
Expanded version of the
yeah.
above.
You can you can use this one also, this one also, or you can use directly this one. Is that clear?
Yes, sir.
Yes, sir.
Yeah. Okay. Advin Keso Jha has raised hand. Yeah, yes, please.
Sir, I have very question.
Can you speak a little bit? Your voice is slow.
Hello.
Yeah, yes, please.
Now it is audible.
Yeah, now it's
Sir, activity question number 10.2.
10.2.
Just a minute. So question number 6 and 7. Sir.
Okay. Just you have to apply the expectation. I mean, formula of expectation, summation of x into px. That's it.
So do you have a post?
Sorry.
I tried.
No, try to. I mean, see. I mean, check your calculation. Otherwise, it's nothing but see what is this? Random variable x equal to x is probability of random variable x, right? So you have to you had multiplied by 0 into 15. What you did? I mean, what was your approach? 0 into 15 plus 1 into 20.
Yeah, then 2 into 30.
No, that's wrong. If you see in this for the second row, frequency is given, right? But in the question, see what how can you compute the expectation value? Summation of x into px, right? That is the probability.
Sir, first
Not,
of all, I've found the relative frequency.
Yeah, first found the relative frequency.
I got one relative frequency, total value is 1.
Yes, total value should be 1. So
And
see, how did you? I think this sum, total sum is 100, right? 30,
yeah,
30,
total
60.
sum is 100. Sir.
Okay, so just 15 by 100. So it will be 0 into 0.15, 1 into 0.20, 2 into 0.30, 3 into 0.15, 4 into 0.10, 5 into 0.05, 6.
Sir, 5. Sir,
मैंने बताया था ना आपको कि उसके बारे में.
Please, who has not doubts, so kindly unmute yourself. Yeah, yes, please. Yeah, okay, so you can go ahead. Hello.
hello, sorry, sir, I was speaking.
Yeah.
Sir, while calculating expected x, what I did, sir, I am multiplying relative frequency with frequency, means 15 into 0.15, 20 into
No, why? So no need. See, what is the expectation? Try to understand here. See. One second, let me sort only. Okay, see, what is the expectation? Summation of x into probability of x, right? So your x values is given what? 0, 1, 2 up to 7, right? Right?
Correct.
0, 1, 2, 3, 4, 5, 6, and 7, right? What is the frequency is given to you?
15, 20, 30.
15, 20,
30,
30,
15,
15,
10, 5, 3, 2.
10, 5, 3, 2, right? Now, if you see, what is this? This is the probability, right? So here you need to find the probability. If you see in the question, it is given that assume relative frequency of random variable is equal to probability of random variable, right? That means here you have to find the relative frequency of random variable, which will is same as the probability of that run. One second. Yeah, here we need to find the relative frequency of the random, which is same as the probability of the random variable, right? So what will be the relative frequency? 0.15. I mean 15 by 100. 0.20, 0.30, 0.15,
0.1, 0.05, 0.03, and 0.02.
So what is the expectation? X into px. So your x is this, your px is this. Okay. So you have to do 0 into 0.15 plus 1 into 0.20 plus 2 into 0.30. That means this value and this value, this values and this value, this values into this values plus this value into this value plus this value. Okay, you got it?
Yeah, got it, sir. Got it. And in sir, question number 7, I am getting answer to 210, but the correct answer is 235, sir.
Okay, so there might be some mistake.
No, maybe.
Okay.
Yeah,
I
the
don't know, sir.
expectation is 2.35 actually, if you calculate. So if you multiply then by 100, it gives 235.
Yeah, because he will earn as 100 points. So after computed the expected value, you have to convert into the 100. Okay.
Not understood, sir.
Excuse me, sir.
Yeah, yes. See, tell me.
Sir, I have a
What
doubt
are the-
regarding the eligibility of end-term exam.
You can ask with the support team actually. They will.
Sir, I asked them, but sir, from last 3-4 days, I'm not getting the clear reply.
Okay. Okay. You have you gone through the what's that grading pattern?
Yes, sir. Sir, actually, what happened? Sir, actually, I was not able. Sir, I was not active for few, like for at least 2-3 weeks. So, sir,
Okay.
I was not able to submit the assignment of maths. So, sir, in all the so like in stats, computation, and English, it is showing that I'm eligible for entrance exam. But for maths, it is showing 37 marks, and for that, I'm not able to write the exam. So I'm confused that will I be able to write the exam for other 3 courses or like this other?
Okay, can you put it on discussion or discourse? We will check it out. Okay, just put this query on discussion or discourse forum. Okay, we will convey further. Okay.
So, sir, actually, at least like I want to know that is there anything that my admission got cancelled because of this? I'm actually 10th. That's why.
Actually, I need to check grading criteria for this. I'm not clear. Yeah, if you know, then you can. Yeah, yes.
Actually, if you if you are not eligible to the particular end term, then you only have to write again the end term, not the whole course again. That's only the point actually. If you get a like chance to write end term exam, then it is good. If you didn't, then you have to only write the end term exam. No need to write quizzes.
Okay.
Yeah.
Yeah, this okay, I will check. Just put it on discussion or discourse. Okay, no worry about that. We will clear this. No need to worry. Okay.
Okay, sir.
Okay. No, don't take too much stress. It will be clear. Yeah. Okay. So where I was? Yeah. If you see, I calculated the x into px, which and the summation expectation is come out to be 2.35, right?
Yeah. Okay, sir.
Okay. If you go to the question, what is the question? In an online football game, for each goal, an online gamer scores, he will earn 100 points, right? Then the probability mass function of given is then what is the expected value of given. So this is the given is something in your relative frequency in terms of probabilities. So you computed your expectation is coming out to be 2.35. Now he will earn 100 points, right? So what is the question? The question is expected number of points, right? The gamer will earn, right? So for each goal, he will earn 100 points.
100 points.
So for the expected number, you got 2.35 as expected. So for one goal, it's 100. Okay. Then for 2.35, it will be 2.35 into 100. That will be 235 points. Is that clear? This is your expectation. For each goal, he will earn 100 points. So for 2.35 goal, he will earn 235 points. Okay.
Okay.
Okay. Is this clear?
Yes, sir.
Okay. After you, Abhinandan has risen. Yeah. Yes, please.
Sir, I have one more question, sir.
Yeah.
Sir, in question activity question 10.3, question number 4, sir.
Activity 10.3. 1 second.
So number 4.
Yeah. Okay, there are 1,000 mobile phones in the mobile wholesale shop, of which 100 are defective. Okay, a retailer buys 20 mobiles from wholesale shop for a total price of 2 lakh. No. 2 lakh rupees. The retailer gets 2,500 rupees profit if the mobile phone is not defective. Okay, and 1,000 rupees loss if it's defective for each phone. What is the expected profit earned by the retailer? Okay, if it's negative, then enter. Okay, so see, what is the question? There are 1,000 mobile phones in which 100 are defective, right?
Correct, sir.
So we have to find the expected value of profit. So for this, one second. Yeah. So if you see, I have to find the expected value of what was question? Profit in rupees, right? Expected value of the profit. So for profit, right? So can I do like I can make there are how many phones? Retailers buys 20 mobile phones, right? So one second. Yeah. So can I do XI? Can I take as XI as profit at the ith piece, right?
Okay.
Or profit of the ith piece of mobile, right? He purchased the 20 mobile phones, right? So
Yes, sir.
that means your I goes to 1 to 20,
20.
right?
Yes, sir.
Now let's compute the for the ith expected profit at the ith piece of the mobile, right? Now what is the expected piece? So if you see, retailer gets 2,500 rupees profit if the mobile phone is not defective, right? That means our XI can take like values non-defective. Okay, let's take a non-defective as 0 and defective as 1. No, it will be something. I can do see, so I can like do -1 and 1, -1 for defective, right? And 1 for non-defective. I can label, right? Now probability of XI will be what? I mean probability of defective piece is what? 100 by 1,000, because if you see, out of 1,000 mobiles 100 are defective, right? So probability of this will be 100
but
by
he is choosing 20 mobiles at a time.
no, I'm computing for one ith piece. It can be 1 2. After that we will apply the expectation of xi, right? I goes to 1 to 20. Is that clear?
Okay. Yes, sir.
Now, so it will be 1 by 10. Okay, 1 by 10 probability for the defective piece. So for non-defective piece will be 9 by 10.
9 by 10.
Yes.
Yeah.
Now what will be the expectation of xi? He is getting 2,500 rupees as a profit when piece is non-defective. That means 25,000 into 9 by 10.
Okay.
Now
Plus 10,000 into 1 by 10. Minus.
He has 10,000 rupees loss when the phone is defective, right? That means loss
Minus
means
10,000.
minus 10,000. Okay, into when it's defective, right?
Right, sir.
So it will be 9,545.
2250.
I think it will be correct answer, right? No.
2250, sir.
225, sir.
2250, right?
50.
Yes.
Minus it will be 1,000, right? That means we get the 1,250, right? Now, so see, this is for the ith piece. He purchases the 20 mobile piece. That means we have to find the expected value for the 20. That means for the ith is 1,215. So it will be x1 plus expectation of x2 and so on plus expectation of x20. That means 1,250 plus 200, 1,250 plus so on plus 1250. That means 20 times 1250, which will be
Two
25,000.
25,000.
Okay.
Yes, sir.
So I think this is the correct one. Let me check answer. Yes, 25,000 is the correct answer. Is this clear?
Yes, sir.
Sir,
Okay.
one doubt, sir.
Yes, please.
Each random variable is independent of other, right, sir? So we
Okay.
are adding them. If it
For
is
see,
not independent, still we
no,
need
for
to
the
add.
expectation, for the expectation case, if variables are doesn't no matter whether it is independent or not. Okay.
Okay, sir. Okay.
For
Always
expectation,
addition.
yeah, always it will be addition. Okay.
So
For variance,
independence
if it's
case, we need to check, sir, for variance only.
yeah, for variance, independence should be there. Okay.
Okay, thanks.
So like in this question,
Mhm.
so first we have to define random variable of our own,
Yes.
and then we
After
have
that,
to
yes.
find the expected value of iPhone from the 1,000 phones, total phones.
No. Total
After
phone he purchases 20.
so, but we are finding expected values of 1,000 mobile now, mobile.
No. Ice goes to 1 to 20. See, what is the question? Try to understand. Question is asking, what is the expected profit earned by the retailer? If you see retailer buys 20 phones, right? So retailer buys 20 mobile phones, and what is the question is what is the expected profit for this 20 mobile phones, right? So we have to consider
Yes,
for the 20 mobile phones. So I'm in first I like to find that what is the profit for ith piece, any ith piece, right? Any of the 20 piece.
yes, sir. Means
So
like this ith piece is from 1,000 mobiles now. Out of
no,
1,000 mobiles.
so what is the question? Are you getting the question?
Yes,
He
I
buys,
understood that out of 20, what will be his expected profit we have to find. So, but when we
yes.
are finding E of xi, like expected value of ith mobile, we
Mhm.
are finding defective, non-defective. For defective, we are dividing it by 1,000, like by total mobiles only, no? So to find the probability.
Probability for ith piece, any piece being defective. Yeah, for probability you have to consider out of total, right? But what
Yes,
is
sir.
our random variable? We are interested in random variable only for the 20 mobile. But probability is what? Favorable case divided by total case. Okay.
Yes,
So
sir.
total mobile phone is 1,000, out of which 100 is defective and 900 is non-defective.
Oh. So because like in while solving this question, I also had in doubt in this. What I
Mhm.
thought was we have to find each case like NC, like only one mobile defective, two mobiles defective, three mobiles defective. So
No,
I thought that there will be 20 cases like NC1, NC2, NC3 up to 20. That's why I was confused and I was not able to solve this question. Now clear, sir.
no. See, now Bernoulli binomial is thing. See, here only two possible is right. Whether mobile will be
Yes, sir.
defective or it will be
Non-defective.
non-defective. So here you have to apply the Bernoulli concept, right?
Okay. Yes, sir.
After that, here we are interested in for the 20 mobile phones. So instead of calculating manually for the 20 mobile phones, we calculated for the ith mobile phone. After that, I applied the properties of the sum of the random variables for the expectation of sum of
Yes.
the random variables. After that, I can directly calculate them. Is that clear?
Okay, sir.
Okay.
Yes, sir.
Excuse me, sir.
Yeah, just please.
सर मेरे को सर वो ये पूछना था एंटम एग्जाम के लिए कि सर आपको मतलब इतना सब आइडिया होगा कि सर मेरे को सर बहुत टेंशन हो रखी है बहुत दिनों से और सर मैं पढ़ भी नहीं पा रही हूँ ढंग से कि मैं एग्जाम दे पाऊंगी या नहीं दे पाऊंगी तो मेरे 2-3 दिन मतलब सर 4 दिन हो गए होंगे सर उनका कोई एग्जैक्ट मेल नहीं आया तो सर मैं बहुत मतलब परेशान हूँ सर आप बता दो इस बारे में
Okay. See, actually, what I'm saying, I have to check actually for the criteria and all things. I will check. What I'm saying, just put your query on discussion forum, okay, or discourse anywhere. We will okay convey further, and you will get the correct answer for this.
सर एक्चुअली कोई नंबर है डायरेक्ट जिससे हम पूछ सके रिगार्डिंग दिस ऐसे
support, you have to mail support@onlinedegree.iitm.ac.in.
सर मैसेज मेल किया था, लेकिन उनका आ रहा है कि आपको रीअप्लाई करना पड़ेगा कोर्स के लिए और सब वापस करना पड़ेगा, मतलब सितंबर का जो कोर्स है उसमें आपको करना पड़ेगा। लेकिन सर मेरे बस मैथ्स में 37 है, उसके लिए एलिजिबल नहीं हूँ, बट तीनों कोर्सेज के लिए मेरे लिए यस आ रहा है एंड टर्म के लिए।
Okay. Then okay, just write on the discussion forum. Okay.
If it's
Yeah,
just
but mobile
yes,
number, Lakshika, you can call directly to them.
There is mobile number is provided, right? I think
I sent it to her, sir. And what I am saying, sir, if she is not eligible in maths, then she can write other subjects.
Others one.
Yes, and for maths you can whenever it will happen, the end term you can write again that.
That's clear, Lakshita. Lakshita, seriously. Just put on discussion forum. Okay, we will convert to the support team, and you will get the correct reply. No worry about that. And someone says they have posted, yeah, for the chat on chat, right? You are
okay, sir.
Okay, so just put on the discussion forum. Okay, we will convert to the support team and you will get the correct reply. No worry about that. If it's showing that you are eligible for the other three courses, then just prepare for that courses. Okay.
Okay, sir.
Okay, because the end term is on 7th of August. So you have to submit graded assignment and all things. So if it's showing as, then I think it should be, I mean, you are eligible to give the exam, give the end-term exam. So just prepare for those subjects for which you are eligible, and the rest of the things just put it on the discussion forum or discourse. I mean, this particular query we will convey to the support team. And
ओके सर। सर एक्चुअली वो एग्जैक्ट मेल नहीं आ रहा था, तो सर इसलिए बहुत कंफ्यूजन हो रही थी, एडमिशन कैंसिल तो नहीं हो जाएगी क्योंकि फीस।
No, not okay. If I don't think it should be there. Just put on this. We will convey and we will get to correct reply. Yeah. What are the criteria? We will let you know. Just put it on the discussion forum or discourse anywhere. Okay. Okay. You have access of discussion forum, right?
Yes, sir.
Yeah. Just yes, please.
excuse me, sir.
Yeah.
10.4 1 first. Do we need to check the variance for all the options which are given, or is there any
I think Pankaj, yeah, I think you have joined late. We have discussed those things. There is no need to calculate the variance of all the things. Yeah, sorry, one second. Sorry. Yeah, what variance tells us? It tells us that see, what is this? Values of x, we have to check. It takes the variation of values of x from its mean, right? So just check the values of x for all options. Okay, if you see mean of this random variable x is 3, and mean of the second option of a random variable is 6, and for the third option is 2.5, and for the fourth option is 5. If you see large variance, large deviation, see, if you see 2 to 6 is -4, 4 to 6 is 2, 6 to 6 is 0, 8 to 6 is 2, 10 to 6 is 4. So only for this option is deviation is large from its mean, for the values of x from its mean. For the another option is less as compared to this option.
Yes.
So directly variance will be more. Okay.
Yes, sir. Thank you.
Yeah. Okay. Abhinandan, all doubts, your all doubts is
No,
clear,
sir.
right?
No, sir. No, sir.
Which one is
Sir, in same question, now one more question has arose. So in the fourth question,
in this
where
one?
you solved. Yes, sir. Right now a fresh doubt has came. So where you solved. Sir, in you told that we have taken random variable of Bernoulli random variable.
No. See, I told actually we have two options. Xi can be defective
or non-defective.
Okay. So it's something I can see here, but our loss is in negative. Okay. So for defective, I can take values as -1, and for non-defective, I will take values as 1. Okay. See,
So like
Bernoulli, no,
it's
Bernoulli
for
trial
0 and
means,
1, yes, sir.
no. Bernoulli trials means what? So 0 is just a labeling for your failure outcome, and 1 is labeling for the success outcome, right? So
Yes,
Bernoulli
sir.
trial means what? Where you have two outcomes, one for success, one for failure. That is the meaning. Okay. For this particular example, it is showing that for loss, if you see, for loss is showing you get nothing, then you have to take 0. Otherwise, but it's showing for loss you have to take as a minus, then you will take the minus. Okay.
So, sir, apart from tossing a coin and rolling a dice, tossing a coin and rolling a dice, where can Bernoulli trial can be used? Because we saw that Bernoulli trial can be applied, but if we take 0 as a label, then our answer will get diverted.
Yeah, David. Okay, let me search. I think.
So,
This is not a Bernoulli trial actually. In this, you can take the two values as minus 10,000 and plus 2,500. In case of minus 10,000, the probability will be 1 by 10, and for plus 2,500,
that
it
I
will be
understood, but like apart for Bernoulli trial, what are the examples apart from tossing a coin?
success and
Any
failure. Whenever you have two
Yeah,
outcomes, success and failure, that is when you can apply the Bernoulli trial.
Suppose your random variable x is okay. You have two options. Either you can get success in which you are interested in, and one is failure. Okay. So you can consider it as a Bernoulli trial.
So, but
Okay.
because here the non-defective part was a success part only, that's why I'm confused. Because in when question arise, what should be labeling, that will be tricky part, no, sir. Like in this, so because getting a non-defective phone is a success only, no, sir. So
No,
can you
but
give
getting a
a
defective
specific?
phone is not exactly failure. It is less than failure. Means it is you are losing money for that. So it is not. It is more than a failure.
See, what is your expectation? Here we are interested in our profit, right? I mean,
Yes, sir.
expected our profit. That means we have to consider profit with loss. Okay.
Yes.
So it was question activity 10.4, right? No, in 10.2.
It's a 10.3 question number 4.
10.3, sir.
Okay, it was in 10.3, right?
Question number 4, yes.
See, what is the question? We have to prefix negative if the negative profit is there, right?
Yes, sir.
So it's mentioned.
Okay.
I mean, are you getting? So suppose for the head tail examples, we are interested in suppose head, right? So
yes.
Success is head, failure is tail, right? So I can take. So is there any sense for tail taking as -1 and for head
No,
taking
sir.
as 1? Not, right? Because if you see, then it will be probability will be what? 1 minus 2 divided by -1, but it will be 0. But for PMF, it should be 1, right? Something.
Yes, sir.
So let it be PMF. So for here, it says for negative profit, okay, we have to take as a minus, right? So for success, if I'm taking as 1, then for failure, I will take -1.
Or you can take minus 10,000 for failure
Yeah,
and
like
plus
directly,
2,500 for
directly the profit and loss as random variables.
See, directly
Okay.
we can take 2,500 for the profit and minus
non-defective
10,000 for the failure.
defective.
I mean defective piece, and probability for the profit is 9 by 10, and no, I mean for non-defective pieces is 1 by 10, which is 100 by 1,000, right?
Yes,
So
yes, sir.
similarly, we can compute the expectation of xi. This is for the xi. It will be 25. I mean, just as the same one. Okay, minus 10,000 into for 1 by 10. It is for the ith piece. So for the I mean 20
basically
purchase, it will be
summation of
I20
all
expectation of
I
xi. Okay.
item.
So
Yes,
if
sir.
you can interpret as well, if you are facing like something, if you are getting confusion in -1 and 1, then you can
Yes,
directly
sir.
do this.
Okay, sir.
Okay. No need to worry about
Yes,
the
sir.
0 and 1. Is that clear, Abhin?
Yes, sir. Yes, sir. Now clear. And so now second question in activity 10.4. Question number 3, sir.
10.4 question number. Just you have to check
Sir,
statements.
and so this third point and second point. So these are the facts, but didn't understand like the meaning. So like ma'am showed us the proof for fourth point, but for second and third, it's like
Hmm.
not clear. What is the cardinality of range of random variable? I didn't understood that line only, sir.
So, I mean, have you
Like I know
understood the
the
meaning?
cardinality is like
Okay.
a set of
What
all.
is the meaning?
So like cardinality
Yeah.
means total number of elements present in a set. Uh, so, but what does this actually mean in this reference? I
Okay,
didn't
see.
understood.
See, variance of a
Yes, sir.
random variable is 0. Then it says cardinality of range of a random variable is 1, right? So
Yes,
suppose
sir.
when variance of a random variable x will be 0,
Sir,
suppose
when it's mean position, at its mean
where
position.
suppose variance of a constant a, what will be this?
So 0.
0, right? So
Yes.
variance of a random variable is x is 0. That means your x is taking a any constant value. That means
Yes, sir.
variance of a will be 0. See, variance of x will be 0 when it's take a constant value, right? X is taking as only constant value. So can you interpret the cardinality of range of random variable is 1? That's it.
So,
Is that clear?
so not really. So means
So
like
tell me. Variance
so
of yes.
so if we take variance of A, it means
Hmm.
E of A square minus mu square.
See, E of x minus
X
mu
square.
is okay. X is
Yes, sir.
is what is A,
A.
right? Mean of
And mu
a
is the
constant
mean.
value will be A.
So mu will be also A.
See, what will you call? See, tell me what is the average of 1,
1 only, sir.
right? See, your x is A, right? Expectation
Oh,
of
so
x will be what? A again.
yes, sir.
So what is this? This is mu. It will be 0.
Okay, sir. Yes, sir.
Now it's clear. Your x is taking only one value, and variance of that random variable is 0. That's it.
So, but
Then
E
cardinal.
of A will give A. How can we say that, sir?
The expectation of x minus mu square is 0, right?
Yeah.
So the all if this x minus mu square is a positive number, it is either 0 or it's a positive number. So if the expectation of all these positive numbers is 0, means individual number is 0. That means x minus mu is 0. So when x minus mu is 0, x is equal to mu. So if mu is a constant, then x is also a constant. So that is why we
Constant.
can prove that it's a
Okay.
constant.
And
Oh,
see, expectation of a constant is same as that constant. Variance of a constant is equal to 0.
okay, sir.
Okay.
Sir,
Yes.
third option, sir. Third option.
And so now the third option, yes.
As the n size of uniform random distribution increases, variance increases. Okay. See, what is the uniform distribution? X is 1, 2, up to n, right? Probability for this will be 1 by n, 1 by n, and so on 1 by n, right? Expectation of x is will be n plus 1 by 2.
Yes, sir.
I mean, you can compute by the formula of
Yes, sir. Yes, sir.
expectation of x as summation of x into px. It will be uh, 1 into 1 by n plus 2 into 1 by n plus so on plus n into 1 by n, right? So I can take 1 by n as a common, so it will be 1 plus 2 plus so on plus n. Okay, this is the sum of
Yes, sir.
n natural numbers, so it will be
N by 2. Yes, sir.
n plus n by 2. This n is, so this n will be cancelled out. So expectation of x is n plus 1 by 2, right?
N by 2.
Now, for the variance, we need to compute expectation of x square. So that means 1 square into 1 by n plus 2 square into 1 by n plus 3 square into 1 by n. Okay.
Yes, sir.
Similarly, n square into 1 by n, right? Now, 1 by n I can take as a common. So it will be 1 square plus 2 square plus so on plus n square. So there is a formula for sum of squares of n natural numbers. This is nothing but n into n plus 1 into 2n plus 1 divided by 6. This is the formula. Okay. So now this n will be cancelled out by this one. So this things is remaining, right? Now, what is the variance? Expectation of x square minus expectation of x whole square, right? Is that clear? Now,
yes,
expectation of x square is what? N plus 1, 2n plus 1 divided by 6. Expectation of x whole square, that means n plus 1 divided by whole square. Okay?
Yes, sir.
Let me add a new page. We got n plus 1 into 2n plus 1 divided by 6 minus n plus 1 divided by 2 whole square. So we
Yes,
can do n
N
plus
plus
1, 2n plus 1 divided by 6 minus n plus 1 whole square divided by 4, right?
Yes, sir.
So here we need to solve this. So it,
Or we can
I
take N
can
plus 1
take n
common.
plus 1 divided by 2. I
2
can
also
take as a
come.
common. Okay.
Yes,
So it
sir.
will be 2n plus 1 divided by 3 minus n plus 1 divided by 2.
2.
Right? Now we can do n plus 1 divided by 2. It will be, if you
4n
cross
plus
multiply it, 4n plus 2 minus
minus
3n minus 3 divided by 6. Right?
Yes, sir.
So n plus 1 by 2, it will be n minus 1 divided by 6. Right? So what?
Yes, sir. N square minus 1.
N square minus 1 divided by
12.
So variance of x is what we get, n square minus 1 divided by, see, for this particular example, you can also memorize the what is the expectation
Formula.
and what is the variance, right? So your variance is n square minus 1 divided. So as you increase your n, your variance will be increasing, right?
Yes, sir. Now clear, sir.
Now it's clear. Third option.
Yes. Yes, sir.
Now.
Thank you, sir.
Okay, thank you. After that, Pawan Solanki average. Yeah, yes, Pawan. Please. Hello. Hello, Pawan.
Hello.
Yeah, hello.
Yes, yeah, audible, sir.
Hello.
Yeah, hello.
Why Pavan mic is showing mute and
Yeah.
he's speaking? How it is possible?
Don't know. Pawan, you can rejoin. Try to rejoin, okay?
You must have joined from 2 devices. That's
Okay,
Oh,
okay. Then
okay.
yeah, yes. What is your doubt? Hello.
So someone, some other person said this, and not the Pavan.
Okay.
As you said to rejoin, maybe he left.
Yeah. Dale has rejoined. Yeah, Dale. Your name is Dale or system name?
Hello.
Oh, your voice is breaking.
Hello.
Yeah, yes, Pawan.
Okay. So 10.6 third
10.6 third question, right? Third question, right? How many
Yes,
of
sir.
have doubt in this question? How many of you had doubt? Is there anybody else who has doubt in this question?
No, sir.
No, sir.
Okay, and who was able to solve this question?
Me, sir.
I was able to solve.
Abhinandan,
Sir,
right? Yeah. Yeah,
yeah,
Sapna?
maybe it is similar, like as you said, the expansion of that formula. Is that?
I mean, had you tried or not?
I didn't, but I can by
Okay, okay.
myself.
So let's do. Okay. See, read the
Okay.
question. Among the random variables x, y, and z, y equal to 2x. Okay. So yeah, let me create a new page. Yeah. There is three random variables x, y, and z. And it is given that y is equal to 2x. And what is the question? X and z are
X and Z
independent.
are independent. X and Z
It is
are
mentioned
independent.
that x and z are these two
Independent.
variables are independent. Right now, what is the steps? If variance of x2 and variance of z is 7, then standard deviation of x plus y. Okay, variance of x is given as 2 and variance of z is given as 7. Then we need to find the x plus y plus z. Okay, so what was your approach, Pawan, for this question? And how did you approach to this?
Hello.
Yeah, yes, please.
Sir, I'm not able to understand. I'm not able to solve this question.
Okay, and Sapna, you wanted to try this, right?
Sir, I tried, but I got wrong answer.
Okay, yeah, what was your approach?
Sir, variance of y, it is variance of 2x.
Mm-hmm.
So I took it as 8, and I got all the three variances, and just standard deviation, it is square root of sum of variance of the three variables.
No, see, you did x plus y plus z as variance of x plus variance of y plus variance of z, right?
Yes.
But Y
Yes.
and Z are not independent. It is
Yes,
not
and
mentioned.
you computed the variance of y. So this is the
Yes. Yes.
not a
Yes.
correct approach. Okay, let's
Okay.
try to do.
Okay.
So variance of
Yeah.
x plus y plus z. Okay, in the question it is given that my y is equal to as 2x.
Yes.
Yes.
My
Sir.
y
Yes.
is equal to 2x.
Yes, sir.
So I can write 2x in the place of y, right? So what this become x plus 2x, that is the 3x plus
3x.
z.
Yes.
So can you tell me what is the variance of ax plus let me tell ax plus y? What will be this one? A into variance
A.
of x plus variance of y.
Yes, sir.
A square, sir.
Sir,
A
A square.
A
into y.
square. That's I wanted to listen from you guys. So
Okay.
okay, so it will be a square variance of x plus variance of y. See, this is the not this x and y. This is the general formula. Okay. Now here x and z are independent. In
Yes,
the
sir.
question, x and z are independent. That means
Yes, sir.
3 square variance of x plus variance of z.
Z.
So it will be 9 into variance of x is
2.
2 plus variance of
7.
7. So it will be 18 plus 7, that is the 25. No,
Okay.
this is the variance. You need to you have to find the
Standard
standard
deviation.
deviation. So standard deviation of x plus y plus z will be square root
Root
of
2.
the variance of x plus y plus z. That means root 25, which is the same as the
5.
So I think this should be the correct answer. Let me check.
Yes, sir, it is correct.
Yes, sir. It
Fine.
is the correct answer.
I was trying to
Yeah.
do this question by the formula which you said
No.
earlier. E equal, sorry, E x minus
No.
that mu.
No. You
E
can see,
square.
you can see, you can guess, you can get an idea. It has given the question sum of the three random variables, in which it says one variable is equal to 2 times of this, and x and z are independent. What will be the variance? See, what is what is meaning of apply that formula in the question? We have just given these things variance. Okay, it's not given like expected value of x is this and the expected value of y is this. Okay, then this kind
Okay.
of things is given, then we need to find that or
Yeah.
it's like expected of x is this one, expected of x square is given, then you have to find the variance of, then you need to find that variance of x square minus expectation of x raised to the whole square. I mean, then there is a application of this formula, right? But
Got
in
it,
this
sir.
question, it's directly given the values of variance of x, directly given the values of variance of z, and we need to find the variance of x plus y plus z, and y is equal to, it was 2x. That's it.
Got it, sir.
Got it?
Yeah.
Is that clear, Pawan?
Yes.
Okay,
Very
Dale has
much.
raised
Yes,
hand.
sir.
Dale has raised hand. Dale,
Yes,
what is?
it's me, sir. Yes, sir. Practice assignment question 2.
Okay, what is your? I mean,
sir.
what's your name first? It's some.
It's Deepa, sir. Sorry, I didn't
Okay.
change the name all the time, sir. I logged in.
Okay, no practice assignment, right?
Yes, sir. Practice assignment question number 2.
Question
I did
number
like
2.
this only, but I did, sir. But I get in point.
This question.
Yes, sir. Just now we discussed, but you do the calculations. I think I did mistake in calculation part.
Okay, variance of 2x minus.
And I got answers with points, sir. That's
And what is
So
the answer?
is she talking about the second question, sir?
Yeah, second one. We
have maybe it is similar like the earlier which
earlier. Yeah, I know that very well. But
now I can.
Okay. Let's do variance of 2x minus y is 3 and variance of x plus 3y as 6, right?
Yes, sir.
So x plus 3y as 6. So
Is equal
what
to
is the
6.
variance of x plus
Variance
variance
of
of?
x
In the
plus and
question,
variance
it
of
is
y.
given that 2x and y are independent, right?
Yeah.
So we have to find the variance of x plus variance of y. Now, if variance of x and y are independent, that means I can write variance of x plus y as variance of x plus variance of y, right? I'm able to write this. Okay, now let's do this. So variance of 2x minus y equal to 3, I can write 4 times of variance of x plus variance of y equal to 3.
Yes, sir.
Y plus, because it's minus 1. So minus 1 is. No. See, what is this? Okay, I got it very good. Okay, so I can write 2 square variance of x.
Yeah.
Plus I can write minus 1 square variance of y.
Yes, sir. Yes. Okay.
Okay, so it will be 4
minus
times
sign
of
is with the y.
Okay, if minus sign is with the y, so I can write 2x plus minus of y.
Yes, that's what I'm saying.
Sir, if it is expectation, we'll get
mistake there only.
Expectation will get minus, not variance, because in the variance.
Not variance, because square is there.
Yeah, square is there, right?
Yes, sir.
So these things we get. Now for this
sir.
equation,
The rest of things I am able to do, sir. Okay, sir.
So similarly,
I did mistakes.
Yeah.
Okay, sir.
Okay, you can proceed further, right? Then
Yes,
you will
sir.
get
Yes, sir.
2 equation. You have 2 constants. You can interpret. You can find the value of variance of x. I mean,
X and variance of y. Yes, sir.
and then apply the variance of x plus variance of.
Sure, sir. Thank you, sir.
Yeah, thank you. Okay, Deepa. After Deepa, there is no raise hand. Yeah, but anybody have any doubt? Okay, anybody have anything else? Where you have doubt something? Any question, any activity, any concept?
It is clear, sir. Not yet.
Okay, let's loudly read is something we are discussing something else. So you have covered, I mean, got the concepts of Bernoulli random variable, properties of expectations, properties of variance, and all things, right?
Yes, sir.
Yes, sir.
Okay. So this week contents are relatively simple than the permutation and combination week.
Okay, but see, permutation and combination
probability
yes,
was little bit
probability
difficult, Bayes theorem and that.
Okay, but your quiz exam was easy as compared to graded and practice, right?
Yes, sir.
Yes, sir.
Okay. See, in permutation, combination, Bayes theorems, probabilities, independence theorem of probabilities, multiplication rule of probabilities, law of all those concepts in permutation combination. You see, if you think, you have to think what can be possible cases, whether I need to apply the combination or permutation, order matter or not matter. So a lot of things you have to consider. But in this Bernoulli and expectation variance, there are some fixed formulas and I mean 2 to 3 formulas and concepts are there. On the behalf of those concept and formula, you have to do the rest of the things. So that's why it's become it's easy. But permutation combination is something which you have to think a lot of. Okay, so here you see one formula is there. Variance of x is same expectation of x minus mu square. Okay, some modification, you get this formula, right? You can apply like expectation of x minus expectation of x whole square something. So what is the standard deviation? So there are some fixed things, right? So that's why it's some kind of something easy. But
Sir, and
it's
one more doubt, sir.
it's also
10.5, question number 3, sir.
okay, it's Deepa, right?
Yes, sir.
Question number 3.
Yes, sir.
This question I have saw a lot of times on discussion or discourse. Okay. What was your approach?
No, sir. Actually, I didn't try this, sir. I couldn't get the
Okay.
properly, so that's why.
Okay. Anybody had tried?
Yes, sir.
Okay. I think yeah. You can tell. I mean, you can tell us. Hello. Yeah. Feel free to. I mean, we can. This is something discussed. So yeah, Lakshmi, please go ahead.
Yes, sir.
Yeah.
It's given variance of number of tickets is 25.
Yeah.
Yes.
And profit for each ticket is 25 rupees.
Yes.
Okay.
So for each ticket it is 25, sir. So there are n tickets.
Suppose I can take variance of x is given is what? Number of tickets sold in a day.
Yes, sir.
Your approach is correct, right? Number of tickets
sold in a day.
Right?
Yes,
sold
sir.
In a day is
25.
So I can let a random variable which represents the number of
And
tickets.
so every day is independent event, so
number
we
of
can
tickets.
add it simply.
Okay, sold in a day, right?
Yes,
now,
sir.
What is the question? That means we are given a variance of x as a 25.
25,
right?
yes, sir.
Now come to the question. You see, for each ticket sold, the profit obtained is 25 rupees, right?
Yes,
see,
sir.
this is the variance for the number of tickets that, okay? Now, for each tickets,
profit is 25 rupees.
Okay. So profit is
25 rupees.
Okay, 25 rupees for each ticket, right? Now, if you see, what is the question?
So like
what is the
25.
variance? Yeah.
What is the variance of profit in rupees square?
Obtained in a day, right?
So
So
25 will be considered as a constant multiplied to random variable x.
Yes.
So 25 square into 25.
Okay. So this is the x is what? X is the number of tickets sold in a day, right?
Yeah.
So for each ticket, your profit is 25, right? So
Yes.
for one ticket, your profit is 25. So for two ticket, how I mean, how
Again
many
25.
No.
No, it's like
50,
variance of
50.
c into x.
Yeah, it will be 50. That means 2 into 25.
Yeah.
For 3 ticket, it will be 75.
Yes,
That means 3 into 25. For 4 ticket, it will be 100. That means 4 into 25, right? So similarly, for the x ticket, how profit will be how much? 25x. 25x. So x is the number of tickets. So for one ticket, profit is 25. For 2 is 2 into 25. For 3 is 3 into 25. So for x, it will be 25x.
Yes, sir. Yes, sir.
Okay. So you have to find the variance of 25 into
x.
That means
25
variance,
square into variance
variance of ax is what?
A
A is
square
squared. Yes.
Yes.
Yeah.
Yeah,
It's
that's
correct
what I,
question,
I,
right?
I did, sir. Straight away
Yeah.
I did.
So 25 is squared times variance of x, right? 25 is squared is nothing but 625, and
625
variance
into
of x is
25.
given to. And what will be your answer?
15625, sir. 15625.
15625 is the.
Yes, sir.
Is that clear, Deepa?
Okay, sir. Clear, sir.
Yeah.
Just
Be,
applying.
I mean,
Yeah,
try
I
to
thought it
focus
was
on the,
complicated, but just applying it
no,
directly.
not
Okay.
just try to focus on the statements of the question. It's literally see,
Okay,
it's
sir.
some manipulation is there, but all the concepts of addition of I mean properties of variance, properties of expectations, Bernoulli
Okay.
will be applied here. Okay.
Okay, sir. Okay, sir. Thank you.
Yeah. Thank you.
Sir, excuse me, sir. One small doubt.
Yes,
It's
please.
coming to the end term exam.
Mm-hmm.
Will it be the portion is all the 12 weeks, sir, or again the focus more will be given for last 4 weeks, or is it like that, sir?
Okay. What is your expectation?
My expectation should be it should be uniform, sir, so that we have covered most of the things till now in a better way.
Uniform from all week, right? No,
Yes, sir.
syllabus
Am
will
I right, sir?
be syllabus will be for whole week.
Okay.
And
12 weeks.
Yeah, for from 1 to 8 week, it will be around approximately 40%, and from 9 to 12 week, it's approximately 60%.
It means more will be towards the end.
Yeah.
Okay, sir. Thank you, sir.
It's approximately not exact, but yeah,
It's
approximately.
okay, sir. Yeah. Based on that, we can focus.
Yeah.
Thank you, sir.
Okay. Anybody have any doubt?
Hello.
Yeah. Yes, please.
Hello, sir. How can find the solution of quiz 2, sir?
Solution of
Quiz 2, sir.
see, Sudhakar, solution is not there, but yeah, there was a discussion session for quiz 2, in which we have discussed solutions of all the questions of quiz 2, right?
Yes, sir.
So you can go through and rewatch. I mean, there is not a PDF for that, but there was a session in which we have discussed in detail. I think we have discussed that. And yeah, you have remembered, I mean, that question, that option in the last question, age of a student in years was numeric and continuous. So we have removed, I mean, we have considered the marking after removing that options. Okay, no need to worry about that. Okay.
Sir,
Okay.
I marked as it is now. I marked the answer as
Which one? Which two are correct, right?
last question, sir. Yes, sir.
Speed of a car, and I think first one was something number of accident. So you have corrected those two. Then see, those who have corrected, I mean, choose the corrected option, they will get answer. And see, we have considered the marking after removing the, I mean, ambiguity options of ambiguity. Okay.
So I will get full marks, right, sir?
Okay, you chosen correct, right?
As
Then
according to the answer key currently available.
Then it's okay. Then you will get marks if you
That
correct.
option itself is removed.
Yeah, option itself we have removed.
Okay.
Because it creates some ambiguity.
Yes.
So that's why we decided, I mean, after removing these options, we have, suppose you have selected two corrected, which is the correct one, and with that option, I mean, age of the student.
So out of 3, if you mark the correct 2, then you will get the full marks.
Yeah. Who has also selected that the correct, I mean, that third option, I mean, age of the student, we have removed that one. We will
So remaining 3 options, out of those 3, those who have selected the correct 2, they will get
correct one. Those will get the correct full marks. Okay. That's right. Yeah, you were right. I mean, there was some ambiguity. It was mistake from our side.
So sir, in the exam, final exam, if we get such a question, we have to consider age as a continuous variable, right? Irrespective of the units.
See, actually, in respect of the age, it's depends on data. You guys also said, because suppose we were thought like 19.3 years, 19 years, 12 days, and 11 months kind of things. That's why we give some continuous data. But
No, sir. Actually, suppose, sir, suppose the person is born in 2000. Then we just subtract the current year from the final year. So we are counting the number of years.
Yeah, you are right. That's why this ambiguity was there. That's why we decided to remove that also. Okay. Anybody have any doubt?
Sir, I had a doubt and a suggestion.
In what?
So means I had a query and a suggestion.
Yes, please go ahead.
So my first query is like after this end term, for the second term, like for Maths 2, Statistics 2, so the syllabus of that term will be only this Stats 2, or it will also include syllabus of Stats 1, sir?
In Stats 2, you will get week 0. In week 0, I mean, Andrew sir had covered. I mean, there is syllabus of, you can say there is a quick revision of more or less all the concepts of Stats 1. I mean, conditional probability based theorems.
Means like my question is for second term of foundation level, the syllabus will be only the content taught in the Stats 2 and Maths 2 and everything, no, sir?
Yeah, related will be there because which topics you have covered in which Stats 1. If you go in Stats 2, related
So
topics.
means like there will be relation between Stats 1 and Stats 2.
Yes. Yeah, that's because it Stats 1 is basic foundation and Stats 2 is some advance of the.
Yes. And so secondly, as suggestions, I also give this in computational thinking and maths. So we can like introduce the option of flagging activity questions, like star marking the activity questions. It will be great, sir. Like say if I solved activity question, then if I have a doubt, I can just tick mark or I can flag that question. That for future I can. Go back to that activity question and actually see that which
You are
question I have
talking about some timestamp kind of things.
No, sir, not on YouTube, sir. On the activity question, like in our portal.
Actually, he want to mark that question for the future reference that he have doubt in that and he solved this question
So
and he
because
have
like
difficulty in that question. So
yes, so like
wants to mark that
for a
question.
week, so we completed the week content in advance, and on the day of like question and practice session, it is difficult to find which question I had doubt, and it becomes hectic, sir. That's why. And so secondly, so it will be great while revision. We can just go through the activity questions and we can see which question I had doubt or was difficult for me.
Okay.
If
That's a very good point, sir. This way we can directly practice more number of times the question that we had doubt in.
Yes, sir. So it will also save the time, sir. Means like repeatedly I have not to find which question I had doubt. And then if I note the questions in paper, sometimes it gets misplaced. That's why, sir.
Yes. Okay.
So it was a suggestion, sir.
Yeah, we'll look into it. We'll look. We'll try.
Very good suggestion, Abhinandan. Thank you.
Yeah. It's a good point. We will look into it. Thank you, Abhinandan.
Thank you, sir. Good day, sir.
Yeah. Okay. Anybody have anything else? I mean, any doubt? Concept related or week 9, week 10, and whatever. So you can ask. Otherwise, we can.
Sir, can we leave, sir, if I have no doubt?
Yeah. You can go.
Yes.
You can
Thank you, sir.
Sir, I have one doubt.
Yes, Pankaj, please.
Sir, when I appeared for quiz 2, there were few more sections which were visible, which I had just registered for 2 courses this semester. But semester 2 also and computational thinking also was visible. So I had not attempted that.